What if I told you the universe might not last forever? Not even close. And the end could come far sooner than we ever imagined. Not in trillions of years. Not even in quadrillions. We're talking about a cosmic end that might begin in just a few billion years. And no, this isn't some doomsday headline. It's serious physics based on real data. The truth is, reality might be stranger and far more urgent than fiction. This isn't your typical end-of-the-universe theory you've heard before. We're digging into new and evolving models that challenge the very foundations of what we thought we knew about time, space, and fate. Instead of presenting one tired theory, we're comparing two radically different, yet both unsettling, visions of the universe's finale, both backed by fresh research and data. The Big Crunch isn't dead. It might be closer than we ever imagined. And Hawking radiation, turns out it could affect everything, not just black holes. These revelations have changed how scientists view the ultimate fate of everything we know. Hey there, tech enthusiasts. Welcome to Not So Techy. We're dedicated to exploring the latest and greatest in technology and scientific breakthroughs. Our mission? To make the world of tech accessible to everyone by breaking down complex topics into straightforward, easy-to-understand videos. If you enjoy this type of content, make sure to hit the like and subscribe button for us. All right, let's jump into it. Here's a question that might change how you see everything. What if the universe doesn't last forever? What if instead of drifting into an eternal, peaceful cold, it's actually on a countdown clock? For decades, the mainstream belief has been relatively reassuring. Scientists thought the universe would continue expanding forever. Sure, it would eventually become cold, empty, and dark, but that wouldn't happen for an unfathomably long time, 10 to the power of 1,100 years into the future. That's a 1 followed by 1,100 zeros. But now something has shifted. Thanks to new discoveries from some of the most ambitious observational projects in astronomy, like the Dark Energy Survey DES and Dark Energy Spectroscopic Instrument DESI. Our assumptions about dark energy, the force that drives expansion, are being seriously challenged. And when researchers plugged this new data into fresh theoretical models, the results were shocking. Some models now predict that the universe could start collapsing within 10 billion years, less time than it's already existed. Others suggest that everything, not just black holes, could evaporate away over time due to an expanded form of Hawking radiation. In this video, we'll unpack both of these deeply compelling scenarios. We'll explore what they mean, how close they really are, and how these revelations might change the way we understand our place in the cosmos. Let's begin with the Big Crunch, a theory that used to sound like speculative science fiction, but now it's gaining surprising traction. You see, the fate of a universe depends heavily on something called dark energy, a mysterious, invisible force that makes up nearly 70% of everything in existence. It's the reason galaxies are flying apart at increasing speeds. For the longest time, we thought of dark energy as a constant, something built into the very fabric of space itself, never changing. This assumption comes from Einstein's theory of general relativity, where a term called the cosmological constant was introduced. The idea was simple. If dark energy is constant, then the universe will keep expanding forever. But recent surveys from DES and DESI, which map out millions of galaxies, have found something intriguing. Their data suggests that dark energy might not be constant at all. In fact, it might be changing over time. And that small change, it can mean everything. One new theory, introduced in a June research paper, offers a radically different picture. It proposes that dark energy is not just one thing, but a combination of two components. The first component is a hypothetical ultralight particle called an axion. This particle is nearly invisible, barely interacts with anything, and might be responsible for the universe's current acceleration. The second component? A cosmological constant, but this time with a twist. In this model, the constant is negative. Why does that matter? A negative cosmological constant would do the exact opposite of what we've seen until now. Instead of accelerating expansion, it would eventually slow it down, stop it, and then cause everything to reverse direction. As the axion's influence fades over time, the negative constant would dominate, and the universe would begin to contract. Galaxies would move closer, stars would collide, and the cosmos would heat up instead of cooling down. The researchers call this the start of the Big Crunch, a reverse Big Bang that ends with all matter compressed into a final, blazing singularity. So when does this all begin? According to their model, this collapse could start around 10 billion years from now, less than the current age of the universe, which is 13.8 billion years. From that point, it would take another 10 billion years to fully collapse, meaning the entire universe might only last about 33 billion years total. Incredibly, that means we're already past the halfway mark of the universe's maximum lifespan, if this theory holds up. Now, it's important to note, this model is still highly theoretical and hasn't yet been peer-reviewed. But if true, it completely rewrites our cosmic future. Now let's turn to a very different, and in some ways, even more unsettling theory. Most of us associate Hawking radiation with black holes. It's the idea, proposed by Stephen Hawking in 1974, that black holes aren't completely black. Instead, they slowly emit tiny amounts of radiation, a process that causes them to lose mass and eventually evaporate. Until recently, we believed this effect only applied to black holes, and it would take unimaginably long times, trillions of trillions of trillions of years, for them to fade away. But now, researchers at Radboud University, including physicist Heino Falk, have shown something surprising. According to their work, Hawking-like radiation could occur around any massive object, not just black holes. That means neutron stars, white dwarfs, and possibly even large planets could be subject to this gradual evaporation process. So how long would it take? Their calculations focused on white dwarfs, the long-lived remnants of dead stars. Traditionally, these were thought to last for a staggeringly long time, on the order of 10 to the power of 1,100 years. But once you factor in Hawking-like radiation, that number drops drastically, down to 10 to the power of 78 years. Still a huge number, of course, but it's many orders of magnitude shorter than we thought. In cosmic terms, it's the difference between forever and just an extremely long time. Neutron stars and stellar mass black holes, those would evaporate even sooner, somewhere between 10 to the power of 67 and 10 to the power of 68 years. Now here's a fun and slightly creepy twist. The researchers even calculated how long it would take for a human body to evaporate from this quantum radiation. The answer? 10 to the power of 90 years. So technically, in this bizarre physics model, you'd outlast a white dwarf. But over the vastest stretches of time, everything would go. Matter would fade. Stars, planets, and particles would slowly dissolve. What we're left with isn't fire or fury, but a cold, eternal emptiness. At this point, you might be wondering, is that it? The lights go out, and that's the end? Well, not necessarily. Some theoretical physicists have floated the idea that the end of our universe, whether it's through a big crunch or total evaporation, might not be the final chapter. It could be the start of something new. There's speculation that a collapsing universe might give birth to a new universe, a sort of cosmic rebirth. This isn't a proven theory. It's more speculative, but it's based on serious mathematical ideas about how singularities and quantum mechanics might work together. It suggests that our universe might be just one in a long series, like links in a chain of cosmic reboots. We don't know yet if that's true, but it opens the door to an even more profound question. Are we part of something bigger, some kind of grand cosmic cycle? So, here's what we've learned today. The Big Crunch might not be just an old discarded theory. It could be the most accurate prediction yet, with collapse beginning in just 10 billion years. And Hawking radiation might affect far more than black holes. It could be a slow, invisible force that eventually dissolves everything, from the tiniest particle to the mightiest star. Yet in all this, there's a chance that death isn't the end, but simply a cosmic reset. It's a lot to take in, but that's the beauty of science. The more we discover, the more complex and fascinating the universe becomes. If you enjoyed this journey into the ultimate fate of everything, go ahead and hit that like button, subscribe to Not So Techie, and most importantly, drop a comment below. Which scenario do you find more compelling? A fiery big crunch or a slow, silent fade into nothingness? Or do you believe in the reboot theory? Let's keep exploring the unknown together.